From the molecular theory of gases, we will determine pressure equation in terms of number of molecules, their masses, and root mean square velocity. Suppose to be certain amount of gas contained in a cubical shaped container whose side length is small l. Thus, volume of the container, that is volume of the gas, is capital V or small v, whatever you will determine, will be equals to L cube. The surface area will be 6L square, as there will be total 6 number of sides. The number of molecules within the container will be N, capital N. The velocity of a gas molecule at certain time will be C1, we will assume it, and root mean square velocity will be C bar square. Now, one more thing, mass of gas molecule will be uniform, that is small m. So, within the box at any instant, supposed to be here is the particle present whose velocity is c1, which we will resolve in three component x, y and z. Now we will make the projections to make it easy. Here from x component, the velocity in the x component x1, in z component z1, and in y component it will be y1. Okay. Now here is the assumption first, which is very important. Each collision supposed to be perfectly elastic. Perfectly elastic collision. Thus, change in momentum of each molecule supposed to be in x1 direction, the x1 will be the velocity, it will be mx1 minus the change in velocity direction will be minus x, so that will be the total change, which is equals to 2mx1. Similarly, we will find out in y direction and z direction. Now, being x1 is the velocity component in x direction, the number of collisions per unit time to traverse the length L, there will be the next collision with the wall. So it will be x1 by L. Thus, total change in momentum per unit time which will be 2m x1 by L multiplied by x1. Similarly for z1 and for y1. Thus 2m from here, x1 square by L plus 2m y1 square by L plus 2m z1 square by L. After taking common 2m by L, x1 square plus y1 square plus z1 square, which can be write 2m c square by L. It will be c1 square for this particle. Now, for the particles n1, n2, n3, etc., supposed to be the velocities are c1, c2, c3, etc. These are their corresponding velocities. So, what we will count? 2m, that is number of molecules. This will be the velocity by L, is the actual change in momentum per unit time for the n number one particles having corresponding velocity c1 at that time instant. Similarly, 2m n2 into c2 square by L thus continues. It can be 2m capital N c bar square by L, where we have already assumed capital N is the number of molecules and root mean square velocity is the c bar square. In the next phase, as we know, pressure will be force per unit area. Here the area is 6L square, which I have already told. From Newton's second law, the force generated will be rate of change of momentum. Thus, 1 by 6L square multiplied by 2m capital N c bar square by L will be the terms equals to pressure. Thus, after simplification, 1/3 m n c bar square by L cube. L cube is nothing but equals to its volume. So, m n c bar square by 3v will be the pressure terms. Thus, pressure will be 1/3 rho c bar square, where rho is the density, which is m n, that is the total mass by volume. It is one equation. Now here, if I cross multiply, PV equals to 1/3 m n c bar square, which is equals to RT for ideal gas multiplied by number of moles. Okay. Thus, c bar square equals to 3RT by m, as we will make it simplify. It is the second thing to remember, where m into number of moles equals to small m into mass into total number of molecules. Here is the M, which is stands for molecular weight. Now, energy E equals to here half m c bar square. It is the kinetic energy of the molecules. So, if we equate m c bar square here equals to 2e and replace it here in this equation, PV equals to 2 by 3 mc bar square, it is capital M into capital E. It will be the third thing to remember, which may be equals to RT if we replace it here.